Meeting is being recorded. So yeah, overfitting, something to watch out when you're training. Overfitting is when, your generated images, like what your model learns, is like super fit and overfit to the data set that you fed in. Yes, here is the slide link. So yeah, it's essentially when the model memorizes the training set and doesn't learn how to generalize off of it. So what this might look like is this is a data set that was, or like a model that was trained on like these electronic product images. And as you can see, there are a good amount of images that look like pretty much the same, like these two, like this particular view of the phone with the hand appears like a couple times. And so there's not a lot of diversity in what's output. Like it's learned a couple of like few examples from the data set. Like there's probably an image of a hand holding a phone in the data set, and the model has just learned like, okay, this is the thing I'm going to generate, but it hasn't learned how to like extrapolate off of that at all. This is another way you can tell if overfitting is happening. So these are interpolation videos, which we'll be learning how to make today, and which I think Runway gives you, it's pretty easy to make one in Runway as well. So if you have overfitting, your interpolation video, we'll talk a little bit more about interpolation, but it's essentially like you are picking a couple of generated images and then like filling in all of the frames in between. If you have overfitting, this on the left will happen where it just kind of flashes really quickly. Like it just sort of knows where the endpoints are, but it can't fill in the gaps really well. But this thing on the right does not have overfitting, and you can see that it's smoother. Like there's a smoother interpolation. It doesn't just kind of like jump really quickly from like keyframe to keyframe. So yeah, overfitting is not necessarily bad. Like the ultimate litmus test at the very end is like, do you like your outputs? Like, is it what you're looking for, like aesthetically or artistically? But yeah, overall, it's not terrible, but it's also not that great because you could view it as you've just gone through this very long, expensive, time-wise process and gone through a lot of effort to just kind of like get back what you put in. Um, but yeah, if you like the results, then yeah, that's all that matters. Some causes, things that can cause overfitting is if your data set isn't diverse enough. So if you have like images that don't cover a wide enough breadth of diversity, then the model's not going to learn how to like extrapolate and create diverse images. Um, Similarly, if your data set isn't large enough, like if you have a really small data set, then each of those images you give it will carry more weight when it's like learning things. So it may like overfit and be like, if you only give it like 200 images, then it may just learn those 200 images and not learn how to like fill in like the gaps in between. Or if your data set contains a lot of duplicates, like if you have like, I don't know, 10 of an image that's really similar, then it may over index on that one image. Yeah, things you can do is like first make modifications to your data set. You can add more images in, add more diversity in your images. If that option is not available, you could augment your data set, which means like flipping, like mirroring it, or doing like closer crops, like we went over last class, to add more diversity and more images to your data set. And in Colab, I would do this last after you've tried the first two. There's this parameter called gamma, which is a little bit in the weeds to explain, but it affects how the training occurs. And yeah, if you increase it, it like affects the way the training converges so that it is less prone to overfitting. The second thing you may run into when you're training is mode collapse. Mode collapse is if you have a data set, like you might have a data set that's mixed, like containing cats and dogs, but your model might only learn how to generate dogs. And in terms of the model itself, this is when the generator, like we remember there are two networks, there's the generator and the discriminator. And the generator is the one that generates new images, and the discriminator's job is to tell, like, this is real, aka from the training data set, or fake, like it was fabricated by the generator. So mode collapse is when the generator just like produces a couple solutions that fool the discriminator. Like it just generates dogs, and the discriminator is like gets fooled on those dog images, but there's no constraint telling it to also generate and cover the cats that are in the data set. So yeah, an illustration of what this might look like is like on the left, this is mode collapse, like where your real data might have like 9 different like areas or clusters, like cats or dogs or birds. But then all of the generated data is like all on one. And hopefully, like what we hope for is that it would be more evenly distributed. And this is actually a structural problem with all GANs. Like there's not really a constraint built in to tell it, like make sure you generate, like you cover all of the data. There's nothing like forcing it to actually do that. And one thing, yeah, this is the way it might come out when you're generating as you're training. So this is a fakes image. It was trained on images from the Biodiversity Heritage Library. So these are like vintage botanical illustrations. And yeah, as you can see, like the flowers don't really look like flowers. They're getting sort of these like amoeba looking like islets. Um, and that's what it tends to manifest as. Um, and here's an interpolation video on a model that has this mode collapse. Like it's kind of cool looking. And this might be like something that is a desired effect. But yeah, these do not resemble the flowers that it was trained on. It just kind of has like these weird, like, I don't know, like almost amoeba looking like blobs and holes. Yeah, and things you can do, pretty much like the first thing I would advise you to do if your training starts ending up looking like this, is to just go back to an earlier pickle that isn't mode collapsed. So if you were in your Google Drive and like you're looking through your results folder, let me just pull it up. Yeah, and you're looking through your results folder and you're looking at the fakes, and then at some point the fakes start looking really blobby like that. I would recommend you just go back to the last good one, and then restart training from there. So like let's say, I don't know, like this one was the one that looked mode collapsed. I would go back to like the last good looking one, and then maybe like one or two before just to be safe, and then restart training from there. Um, yeah, and the reason why this would work is because the training itself is not the same every time. Like there's a little bit of randomness injected. So if you like rewind and back up and start at an earlier pickle file, um, like you're rolling the dice again, and it probably won't collapse in the same way. And then there are also these options that you can edit with how the model trains. This is the learning rate, and these are learning rates for the generator and the discriminator. Yeah, these just kind of like with same with the gamma on the previous slide about overfitting. These are just like parameters that affect like how it trains. So with like a lower learning rate, that just means that it takes smaller steps when it's training. Like training might take longer, but it might be less prone to like jumping in these areas of mode collapse. Yeah. Any questions about that? Nope. Okay. Cool. So that is it for like things you should watch out for. Um, so now we're moving on to doing inference in Colab, which is just generating stuff from your model that's already trained. So today we'll cover a couple of different things, a bunch of different things you can do. Hopefully you can follow along. And so I'll have I'll have time for y'all to like play around in Colab or also just like work on things for those of you that still want to train in Colab. But yeah, the first thing we'll do is generate images. Then I'll introduce a bunch of different interpolations. Noise loop interpolation, if you remember in our second class, we all did noise loop interpolation with models that were pre-trained. And now we're like coming back full circle and now doing the same thing, but with models that you've trained. And then linear interpolation and flesh digressions, which is a strange name, but yeah, it's a cool technique. And then the last thing we'll end with projection, which is always a lot of fun. Projection is when you take an outside image and then you project it into your model. So yeah, this is the only one where you actually have more of a control, like you input an image and then that image determines how the animation plays out. And I've linked the Colab notebook here. I'll also put it in the chat. And also just make sure when you're using this Colab notebook to make your own copy for yourself. Okay, cool. Yeah, I'll give a quick refresher of the latent space. Like I went over this second week of class when we were doing our noise loops, but yeah, a big blast from the past from like a month ago. Yeah, a latent space. It's like this 2D space in this illustration, and there are points, and each of the points corresponds to an image that the model generates. So the latent space is like a thing that the model has. It has this space, which is its understanding or like its mental model of how these images are laid out. And these are its generations. So you have like a point. In the notebook, each of these points will be called a seed. And each of these seeds corresponds to a particular generated image. And different seeds will correspond to different generated images. And seeds that are close together will generate images that are close together. Like these two are pretty close, but there are like slight differences in the hair here and the bangs up here. And yeah, the nice thing about latent space with these GAN models is that they're smooth. So you can start at one seed, and then for each of the points in between, generate a frame. You tell it to generate the frame, generate the frame, generate the frame, generate the frame. And then it's like a smooth interpolation between these two seeds. Yeah, and that was like I've illustrated this as a 2D grid, but the like that's a little bit of a simplification. Stallion actually has a latent space of 512 dimensions, which is a lot bigger than 2. But yeah, it doesn't, for our purposes, each of these points still corresponds to a seed value, which you'll see in the Colab notebook. But yeah, just know that they're not, yeah, it's just a big vector of 512 numbers that you can also specify with a seed value. So yeah, the very first thing we'll be doing is doing inference, which is when you take one seed from your model and then generate the images. So yeah, here is, I'll go to the Colab notebook, and then yeah, you all can have some time to generate images, or also just yeah, have open work time to work on things and ask me if you run into things. But yeah, we're here in our Colab notebook. I'm going to hold on. Let me switch to my other account. Okay, so we're here in Colab. Yeah, like as always, these first couple cells are set up to connect your Google Drive and everything. You can see that I got a V100, which is like the best GPU Google Colab Pro offers, which is really nice. It would come in more handy if I was doing that. Sorry, I think my Zoom crashed for a quick second. Let me share my screen again. Yeah, so I got a V100, best GPU that Colab offers. It's nice. Wait, Sam says, is it going to be an issue if I have two running things in Colab at the same time? No, with Colab, you can have three things running at the same time. But if you have more than three, it'll tell you to close one of the sessions. Yeah. So yeah, you could actually like have three trainings running at the same time in three different tabs if you wanted, if you had different data sets. So yeah, my drive is now mounted, and this is to update the repository, the Stalgan 88 PyTorch. This is just a folder that's saved in your Google Drive. This part right here, you may or may not need to run this. If you've only done training in Runway, or you want to use a pickle file from Runway, you will need to run this cell. But if you've done the training in Colab, like with the notebook that I sent you all last week, you don't need to run this cell because your model is already compatible with this. Yeah, the reason why this is just a cell that converts a model from TensorFlow to PyTorch. And yeah, they're just different, like kind of different formats that these models are stored in. And yeah, this notebook and the latest that NVIDIA released for this particular model, Stalgan, is in PyTorch, and then previous models were released in TensorFlow. And Runway still uses TensorFlow. Yeah. So if you have a model from Runway, you just upload it to your drive or to Colab, and then replace this path with the path to your model. And then here, this is where you would tell it where you want it to be saved, like the new name as the new PyTorch model. And that'll just convert it so that you can use models from Runway in this notebook. So yeah, Sabrina, you might want to do this with the Runway pickle.
Okay.
So yeah, to inference and generating images, yeah, it's overall pretty straightforward. There's just the script generate.py. This out directory, you'll tell it where you want to save it to. like here I've specified it'll just save it here on the side as content out images. I might also, like if I wanted it to just get saved directly to my Google Drive, I could also just put in, like tell it to save directly into my Google Drive. SSHH generated images. This truncation value is, it's a parameter that'll affect how the images are created. Truncation is, it determines how realistic the images are. So it's like a number that, like if you set to around like 0.5 to 0.8, it's like pretty, it has like a good amount of diversity, but isn't very, it isn't like super realistic. If you wanted an images that are really realistic, but they'll have less variation in them, you could set it to like 0.1. But usually I stay around like 0.8 or 0.7. Yeah, most people choose between 0.5 and 0.1 or 1.0, but you could set this to like, I don't know, 50, and you get something really weird and colorful and kind of strange. And it wouldn't resemble things from your data set that much. But yeah, if you're looking for stuff that's like weird and at the fringes of stuff, you can like just change this number to a number that's very out there. But yeah, I just suggest on your first go, you can just leave it as is and then tweak it as you want and see how it affects your outputs. This seed value, so this, these are the seeds I was talking about, like with like saying like each of these is a seed. They're called seeds here because they correspond to random seeds. Essentially, like one number corresponds to a different vector. So seeds could be like 0, 50, 1, 25. They range from 0 to some really high positive number. So you could put in like 4,000, and that would be a seed as well. The thing to know about these numbers, these random seeds, is that they're just labels for these points in this latent vector space. So seed 0 and seed 1 have no relation to each other, even though they're like numerically close. Like they're just as randomly generated as 0 and 4,000. So this, if I put in this, this will generate 4 images. Let me just go ahead and run this. So this will generate 4 images from these seeds 0, 1, 25, and 4,000. And yeah, it'll put them here in content, my drive, and then in, yeah, seems like it'll probably create this folder once it's done running. But then, yeah, as usual, you here in the network input the path to your pickle file. So your path to your pickle file would be in the results folder in Colab SGD2 88 PyTorch results. And then you'd grab the one, yeah, the one that you want to generate from. So you might just like go and grab the latest and grab this path. Or in the case of Kevin, like where you liked an earlier one better, you would go find the one that corresponds to the one that you liked and then use that one. So we can see that this is done. So it said it was generating the images for these different seeds, seed 0, seed 1, 25, and 4,000. Let's see, right, SSHH generated images, and we have these four seeds. We can download them and check them out. Let me share my entire screen. So this is a model that I had trained on Chinese paper cuts. So we can see we have some, yeah, some nice paper cuts. And they're each named by the numerical value of the seed. One quick trick, if you want to just generate a bunch of things, is you can, instead of separating these by commas, you can put a dash, and then it'll just generate all of the seeds from like 0 to 50. So if I ran this, it would generate 50 different images, and then you can zip up the folder. So you just put in the path to this folder, and then zip it up and download it. And then you'd have like 50 that you could just choose from really quickly. These seeds are nice. They'll come in handy because like if you type in seed 0, it'll generate exactly the same image every single time. Or yeah, you'll need the same seed and the same truncation value, and it'll generate the same image every single time. And that'll come in handy later when we do linear interpolation. Because yeah, you just specify the different points by different seeds that you want it to interpolate between. So yeah, essentially the workflow is like you generate a bunch of images, then you download the big folder, and then you pick out, I don't know, like 5 or 6 that you like that you want it to interpolate between in that order, and then you can put them here. Yeah. Any questions about that? If not, we can go. Let's go on break until 20 after. And also, yeah, after that, we can have some open work time where y'all can generate some images, and yeah, and I can help you all debug or help those of you that want to catch up with catching up and debugging. Okay, see you all at 20 after. Yep, so that was like how to make images. Yeah, and again, a quick trick if you want to just generate a lot is you can just say like generate seed 0 to 500 or 5 or 50, and then that'll just batch generate a whole bunch that you can look at and flip through. But yeah, there are a bunch of different videos you can also make aside from static frames. Sam already got into the noise loop. If you remember the noise loop, we did this the second week of class. Essentially within the latent space, it just starts at a point, a random point, and then just randomly like does a noise, simplex noise, and like walks around, does a random path, and then comes back. In general, this will create like all of these lines are kind of curved, and so there won't be a lot of like inflection points like you usually see with other kinds of interpolation. You don't have that much control over it. You pretty much just like tell it like make a noise loop, and then it'll make a noise loop. And you can tell it like how long you want it to be, but you can't really control like what the content is itself. So these are from our second week of class. Sam's work or Sam's noise loop, and this was Eddie's with the pre-trained Beatles model. But now that you all have trained your own models, you can do the same thing, but with like your own content in your own data set. The second kind of interpolation is linear interpolation. Compared to the noise loop, this one you have more control over. So you can specify like interpolate between seed 25 and seed 50. And you can like actually tell it like, this is the content I want in the video, and I want you to interpolate between these frames. The way the script is written, it'll move from the seed to the different, from seed to seed, and generate an equal number of frames on each leg. So it might generate like 50 frames on this leg and 50 frames on this leg. And what that effects is the speed. So sometimes with linear interpolation, the speed can feel uneven because like if you're generating 50 frames here and also 50 frames on this leg, and this one's actually shorter than this one, this segment will feel faster when you watch the video because it's covering a longer distance in the same amount of frames. So that's just something to keep in mind with linear interpolation. Yeah, in general, it'll feel like you're going from like A to B to C, and like it'll kind of pause a little bit on each one, whereas the noise loop will be pretty seamless and smooth. And one cool thing with linear interpolation is you can make the start seed the same as the last seed, and that's the way you can create a looping video. So like, yeah, if you wanted to make a looping video, it's pretty easy to do. So if we go over to Colab, this is where we just were. Um, for linear interpolation, it's pretty much the same. You specify your out directory where you want it to be saved. Um, these these you don't really need to change. If you wanted to play more and dive deeper, you could change this from Z to W. Basically, there are two different kinds of latent space. And you might get like very slightly different results if you use Z over W. Truncation value, it's the same as up above. So up above, we use like 0.8. So if you wanted like exactly the same image you got before, like seed 0 with truncation value 0.8, then you would make this like the same number, 0.8, and the same seed. And then you would get the same, like exactly the same image. If it's like 0.5, it might be slightly different, but still pretty similar. And this is where you specify like the keyframes. And yeah, if you make the end the beginning, you get a looping video, which is nice. And then you stick in your pickle file and you just run this and it'll be output in this directory right here. The noise loop, so this will go ahead and generate and stick it in this folder. The noise loop, pretty much the same. This one you don't specify seeds. Like I said, you have a little less control. Yeah, pretty much the same. You specify your out directory, your truncation value. These you can fudge with a little bit. The diameter specifies kind of like how wide that loop is. If you make it small, it'll traverse a smaller loop, so it'll cover less diverse content. If you make it a big number, it'll like do a big walk, and so it'll cover a lot of content. And yeah, this random seed is just to specify what the starting point. Yeah, a small thing is that the seed is not the same seed as up above. This is just some random number that specifies like where your starting point is. So if you just want to make different noise loop videos, you would change this number to a different number. But overall, you don't have like that much control when you're making noise loops. And then yeah, stick in your pickle file and run this. And then you should get some stuff coming out. And last but not least, or yeah, this is linear interpolation. If you're using Runway and like checking out models in Runway, linear interpolation is what they offer you. So this is like exactly the same thing, but in Runway, it's linear interpolation. So if you like go to these latent videos, all of these are just linear interpolation. So if you were like generate latent walk video, this will give you an interface where it's pretty much doing exactly the same thing we're doing in Colab, but in Runway, where it gives you like a selection of images and you pick which ones you want to be your keyframes, like this one, and this one, and this one. and then that'll export the linear interpolation video. But yeah. And then for your own trained model, you can do the same thing. It'll be the same interface. Yeah. So just know that all of the videos in Runway are just linear interpolation videos. And the very last thing, I've kind of grouped all of these video creations together. There's this third one called flesh digressions. This one will create a little bit of a different effect. It'll kind of like take your content and like mirror it in a bunch of places and like smear it in a circle. Yeah, it's from this this AI artist who, yeah, kind of like they call it like GAN surgery, where they're doing like one circular interpolation in one layer while another different circular interpolation is happening in a different layer. To be honest, I'm not too clear on like exactly what's going on, but it creates like this cool like a smearing effect. And yeah, here's another one. This is a model that I trained on flowers, and yeah, it's in my background. But this is just a model trained on flowers and then put through this flesh digressions. And yeah, that's just right here. This one is also pretty straightforward. You just type in your pickle file and you can leave these as is. This PSI is the same as truncation. But yeah, you can just kind of like run it as is and get a flesh digressions video out. So I'll give you all like 10 minutes. You can feel free to just pick one of these and then make your video. And then if you have extra time, you could try the other two. Yeah, so yeah, go ahead and make some videos. We can circle back at like 55.
Where do you find the linear interpretation on Runway? Interpolation, I mean.
Yeah. For your own model or for models that they have already?
On my own.
So let's look. I'm here in train, and these are ones that I've completed. Let's see what this says. Yeah, so this is a cat model. If you click add to workspace, then you can click export, and then it takes you here. Generate latent walk video. It's a little bit hidden. Like I think like anytime you're using a model that you've trained already, you have to go through that flow.
Okay.
Mm-hmm.
Is there a way to make it faster? Or is it more about like changing maybe like I tried a linear interpretation and shared it in the Slack channel. And if I want to see like more change or like more movement, what's the best way to try that?
Yeah, I would say go and like yeah, with linear interpolation, what you have control over is like those keyframes. So I would say go ahead and like maybe generate let me play this. Go ahead and generate like I don't know, like 50 or 200 and then pick ones that are very different. And then like interpolate between ones that are very different.
Oh, I see. Because I left, there were two values in the seeds area, like 463 and 470, which I think were just there by default. So
Yeah.
do I need to choose sorry, I'm sure you went over this. Do I need to choose a range or do I put in like just 2 or like 5?
You could put in like you could like a comma separated list, like 0 to 26, 42, 50. And then you can make it as like long as you want. And then like if you want a looping video, you can end on the same number as you started. So yeah, this
Right.
video itself is only interpolating between two seeds, which is why there's not a lot of movement. It's just starting at one point and then ending at another point.
I see. And so those numbers that we're putting in are seeds, but even like 0 and 1, for example, could be like very different, you were saying.
Yep. Yeah, the only way to really know is to go to the image generation part and generate the seeds for those and then see what they look like.
Right.
So yeah, usually I'll go and generate like 50 or 200 and then pick the ones I want it to interpolate between and then stick that into the list for the linear interpolation script.
Cool. That makes sense. Sorry, I think the last question is there's a field where it says you can set the number of frames. I didn't set it, so I just went to the default, I think 240. Um, but we could just set that, I guess, to whatever works.
Yep.
So would the number of frames change the length of the video?
Yeah, I
Or-
think the number of frames, yeah, you might want to double check on this, but I think the number of frames specifies like how many frames are between each like leg, like between each of the keyframes. So if you have like 6 seeds and your frames is 200, then it would be like 200 times 6 frames in total.
Oh, that makes sense. Because yeah, I put in a high value, but then put in 10 seeds and the video is going to be way too long. Yeah.
Yeah, I accidentally did that on one over here. I'm just like waiting for 1200 frames to come out. Like, oops. Well,
A riveting film.
hopefully.
Can I ask if we trained our like network on an image size of like 1024 by 1024, does that mean that like I think you said the matrix or the vector was like 512 long, or is it for 1024 by 1024 image, would it be 1024 or does it always kind of like go down to 512? Is that
It's 512 for the images that are 1024.
right?
I think it's like 256 if you train on like a 512 by 512 model.
Right. Cool.
Yeah, it's just like a property of how like the network is structured with the architecture. Like it takes the image and then like shrinks it down, and then that's like it represents the image by like these 512 numbers, and then it like regenerates images from there.
Yeah, it's kind of like bringing me back to like high school math and vectors. I'm just picturing like a very tall thing in bracket.
Yeah, totally, exactly.
So each image is one of those.
Yeah, and the generator, like the generator's job is to translate between like this long, I don't know, this long like list of numbers to an actual image.
Right. is that long list of numbers the equivalent of like one of the layers from the, I'm forgetting the name of the video. The
Oh yeah, the 3 blue, 1
yes,
brown.
yeah, 3 blue, 1 brown. Like each one of those was like a layers. Is it kind of like a strip of one of those layers? I'm just trying to figure out like what's the relationship between a vector and a seed.
So a seed, like a seed is just like, I don't know, seed 2 corresponds to some randomly generated list of 512 different numbers. It is pretty similar, like in the 3 blue, 1 brown video, like the different layers. Like the vector is the input to the generator. So if you have all these different layers, at the very beginning, you say, okay, I'm going to input these 512 numbers, and then those 512 numbers, like I don't know, they get multiplied and added together through all the different layers, and then at the very end, out comes an image. And so if you put in different 512 numbers at the beginning, you get out a different image because you have like
Right.
different numbers that it starts off with that get like added and multiplied.
Right.
Mhm.
The way that it's been explained to me in the past that was helpful to understand seed is that when a program does something that's random, it's still like random is a program and it's in and of itself. So it's like it can't be completely random. So like each step of the program is going to be like a similar number. It's going to be like the same number in that program. So like every time you run that program, it'll be different, but like within that one instance of running random, like you can go back and like reference those numbers.
Yeah, exactly.
I don't know if that was super clear, but yeah.
Yeah, that makes sense. I think there's, yeah, and I've seen that in like After Effects, or similarly, there'll be like a seed.
Mhm.
Yeah.
Mhm. Well, we're at 55. Did y'all generate some cool interpolation videos? Let me check the Slack. Nothing in the Slack. Yeah, I saw that Sabrina, you sent this out earlier. But
Oh,
yeah, there's an interpolation.
little bit. I'm exporting another right now, but it's taking a minute.
Sweet. Yeah. Like the fleshy faces are kind of unsettling.
Yeah, are these like people on the beach or like standing in front of a sunset? Is that what
It's like a lot of images of men holding fish.
Oh, I forgot that that's
Okay. Well, now I'm going to go over the very last thing that this one is like a lot of fun. A lot of people have a lot of fun with projection. Well, first, are there any questions about interpolation and making those videos? Flesh digressions, I think, is like can be really surprising what comes out and really fun what comes out. Noise loop and linear interpolation are like a little bit similar. But yeah, projection. A lot of people have fun with projection. It's when you take an image from like any image at all, like you search something on Google Images or you take a picture of yourself, and then it finds the closest approximation in your model. Like you might start at like this picture of yourself, and then essentially what happens in the animation is it just tries to get closer and closer to your face. But it won't ever really get like your face exactly or whatever image you input exactly, because like this input image wasn't in the model. So it'll start off in some random spot and then try and get closer and closer. And it'll never really like actually really get there. I think I have another projection video. Yeah, this one was this cat into my paper cuts. Yeah, but it won't get to the cat. It might get kind of close or not because they're so diverse or so different from each other. But yeah, projection is fun because it's a way that you can kind of guide how these generations happen by putting in an input image. And yeah, in the Colab notebook, it's pretty straightforward. The one thing you will need to do differently from the other ones is that you'll need to input an image. So you'll need to like upload an image like 1024 and then upload that and then put the path right here. And yeah, change your network file. And then that will go ahead and like output that projection. So yeah, like before, I'll give you a couple minutes. It's also, we're nearing the end of class, but I'll stay on for like 5 or 10 more minutes if y'all want to like hang out. But yeah, if not, like, yeah, I'll see you next week. And so we can see this is generating. Wow, it's done. And it's saved right here.